So in this video, I'm going to talk about how to name alkanes, like the basic rules that you need for that. But I do know that you're probably going to need some more practice. So I've got that in some other videos, but I'm probably going to make you some practice problems shortly. So when we're dealing with alkanes, the first thing we need to know is how to name straight chain alkanes. So if we just have one carbon, we would call that methane. That would stand for CH4, and that would be by itself. So just CH4 like that. As we move up, we're going to change the beginning of that name. So this becomes ethane. So ethane would have 2 carbons. And then we get to propane. So that's going to have 3 carbons, and that's going to have 3 in those ways. So I've represented this in multiple formats, right? Then we get up to 4 carbons, which is butane, okay? So that's going to have 4 carbons, like you see there. Next, we have pentane. So pent is 5, and that's why we have these in multiple ways represented with 5 carbons, okay? Next is hexane. Hexane has 6 carbons. 1, 2, 3, 4, 5, 6. That's what we have there. Next we have heptane. So that's a Heptane. That's 7 carbons. So heptane. 1, 2, 3, 4, 5, 6, 7. You may be familiar with an octagon, so that would be oct is 8. Octane is 1, 2, 3, 4, 5, 6, 7, 8. I think this one sounds funny because 9 is called nonane, like it is non-existent. So 1, 2, 3, 4, 5, 6, 7, 8, 9 there. And finally we have decane, would be 10. Now you can keep going up. For example, 12 is dodecane, which kind of makes me laugh as well because it sounds like a dodo bird, but there's several different options that are there, okay? So when we're looking at naming things, there's some basic rules that we need to get to. And those basic rules are basic things, and we can get into much more detail-oriented stuff as we move further. Believe it or not, this is kind of the basics. So the first thing that we need to do is to be able to select the longest chain. Now, here's the thing, y'all. Sometimes the longest chain is not obvious. For example, if you have something that goes like this, and we have stuff going in different directions. So notice I put stuff here. It's not necessarily going left to right. It's not even going up and down. It's winding. So we would have the longest chain go in this direction and then it goes down. So sometimes you just have to keep counting and figure out what the longest snake is. And that would be the longest chain. If 2 chains are the same length, then you want to use the one with the most number of substituents. So what that means is that you have more substituents that are smaller and less complex. What's a substituent? Well, a substituent is anything that's coming off of that main chain. So like I drew over here, these things are not on the main chain, so we still have to name what those things are. Those are both methyl groups. One methyl group is the difference between a drug that will work and one that will not. So yeah, those make a difference. So I'm representing these as having an R and then whatever else that's there. So an R group is just anything. It could be anything that's there, and we have a CH3 connected, just like we see up here, right? So that would just be one CH3 connected. Just like with the chain names, this begins with the term meth. And then instead of saying ane, we put a YL, so that becomes a methyl group. 2 carbons would be an ethyl group. 3 carbons would be a propyl group. Oh, but wait. Now when we get to 3, we can have different arrangements of stuff. So that R group could connect here on the first carbon, or it could connect on the second carbon. So this makes sort of like what I consider to be a forked tongue. So I call this an isopropyl. So that's where you have a forked tongue on the end. Now, probably the better way to name that, though, is that it would be a 1-methyl ethyl. And here's where I get that from. So the long chain that's coming off of that R group has 2 carbons. So that's where ethyl comes from. And then this would be a methyl group. I will take either of those. That is totally fine, but we are not going to use common names. Okay, you don't need to know those. When we get to butyl groups, there's 4 carbons, and that means you can have many different types of arrangements of them. So butyl that's just connected straight chain like that would be a butyl. We could also have isobutyl, where it's connected sort of in that forked tongue at the end. So again, that would be 2-methyl propyl. So those two things would sort of be the same thing. We could have what's known as sec-butyl. So it's connected at the second carbon of that butyl chain. So let's see here. We can have this 1, it's connected to the second carbon. We've got 3 there, 4 there. Another way to name that would be 1-methyl propyl. So that's another way to name that. And finally, the way that I tend to name these guys is I name them tert-butyl. Another way to name that, though, would be 1,1-dimethyl ethyl. Okay, so here's where that comes from. So we've got an ethyl group of 1, 2. If you want to pick a different one, that's fine too. And then we've got a methyl group coming off of that here and here. So that's where the 1,1-dimethyl ethyl comes from. Tert-butyl kind of seems easy in comparison to that to me. So, do it your way. That's totally fine. Okay. So the third thing is if the chain is a ring, we're going to add the term cyclo in front. There's slightly different rules when it comes to cyclos versus chains, which we'll talk about a little bit today, but really a little bit further. So if we have like a pentane that's wrapped around itself, that would be a cyclopentane, or a cyclohexane has 6 carbons. A cyclooctane has 8 carbons. Okay. Next, we look at the parent chains and how to name those. Okay. When you're naming parent chains, we should put the substituents in front of what that parent chain is named. And the substituents are going to go in front. They are arranged alphabetically. Okay? I'm going to talk about numbers in a minute. Numbers are where you place things. The alphabet is what puts things in order. So there's some exceptions here on the alphabet, though. When you have something like di, tri, tetra, things like that, or if you have tert and sec, because those are in italics, that's sort of how you can tell that those are the two things that we're not going to use. They are not used when considering the alphabet. So if we have a methyl group, an ethyl group, and a heptane, heptane's going to come at the end. Ethyl is going to go first, and methyl will be in the middle. Okay. So you'll get better at identifying what is the parent chain. So like here, the parent chain is going to be cyclopentane. And we have 2 methyl groups, and we have an isopropyl group here. Okay. So the iso is actually considered when we're trying to name that in alphabetical order, but the di is not. So that's something to consider. So now we have to identify the substituent numbers. And here's how we look at that. When it comes to like a chain, we want to get the first substituent to the lowest possible number. And that is important because chains are slightly different, as I said, than cyclos. Okay? If they're tied, then you want the lowest number for the first substituent. Lowest possible number for the first substituent. And then, if you're tied still, then the lowest possible number for the next substituent. When it comes to rings, however, the total numbers, if you add them all together, should be the lowest possible number, okay? So let's talk about that. So here we have the example from above. We've got heptane. Heptane is going to go at the end of the word. I know that I'm going to start numbering here. And I don't start here because look, 1, 2, 3, 4, 5, 6, 7. If I did it that way, then the ethyl would take on a 5 and the methyl would take on a 6. Well, those numbers are just way too high. So we don't want to do that. Instead, we're going to go with the numbering in red, because what that effectively does is it allows us to put this number on the first substituent we would come to if we were numbering from the other direction, and this number on that ethyl group. Now, we number one way, we alphabetize next. So 3 goes with the ethyl. Don't get those backwards or you're going to give a different structure completely. So 3 goes with the ethyl. 2 goes with the methyl. And since E comes before M in the alphabet, ethyl goes first, even though it's a higher number, okay? So 3 ethyl, 2 methyl, heptane. And so the methyl heptane runs together. You have dashes go between numbers and letters, okay? If you have 2 numbers that are the same, you put a comma between them and then a dash before the number, or before the letter, excuse me. Okay. Next, we're going to look at the other example with the cyclopentane that we had there. In this case, I could number 1, and then I could do 2 here, 3, 4, 5. Now, the alternative would be I could number this 1, and this would be 2, right? So thing is that I have 2 methyls here. So if I number the way that I had written first, which would be this way, it would be 1 plus 1 plus 2. So that's where that would be 1 plus 1 plus 2 would be 4, okay? If instead I were to number this and say this would be 1, this would be 2, 3, 4, 5. Well, if I did that, then the isopropyl would be 1, and then each of the dimethyls would be 2, and 1 plus 2 plus 2 is equal to 5. That's a higher number. So you don't want that one. You want the one that has the lowest total number. That would be your 4. And for that reason, this is going to get number 1, and this is going to get number 2. Now we put things in alphabetical order. So it becomes 2 isopropyl dash 1 comma 1 di, meaning you have 2 methyls, dimethyl cyclopentane. Let me guess, we need to practice, right? Notice what I have here. Practice a lot. Oh yeah, and by the way, straight chain alkanes are less stable than branching chains. At least that's what we're finding with when you do some combustion reactions, okay? Just mentioning that before we move on. So we need to practice. Please do practice. There's 1,000 practice videos on the web. I would certainly encourage you to use those, and hopefully I have one up soon as well. Thank you very much.